Okay, we are on to video 2 of waves, and I've got more terms for you. So last time we did we did frequency, period, wavelength, and amplitude and velocity. Now, one of the things I forgot to tell you about amplitude is it always goes down. So you start with this much energy and it dampens. Eventually the energy is lost. This happens in every wave. Amplitude always goes down. Think about if you yell something, if you're standing right next to the person, they hear it really well. But if they are a ways away, they might not barely hear it at all, and that's because of amplitude is dying. Water wave might start really big at the origin, and then it trickles down to smaller and smaller as it moves towards shore. So amplitude shrinks. In this particular set of things, we're going to talk about reflection, refraction, and diffraction. And this is what happens to waves when they hit a boundary. Okay, and this is going to be the boundary on this little wave that I'm about to create for you with this. And reflection is the wave bouncing back. So it goes one way, and then it hits something, a boundary of some sort, and it bounces back. In sound waves, we call that an echo. Now, it can have a lot more impact than just an echo. Refraction is the bending through a medium. Some of you have played with light waves, and one of the things you're going to be able to do when we do the next project is put like a toothbrush in water and the bottom of it, or a pencil, and the pencil looks like it's broken. It's like cut in half. And that's because the waves that your eyes are seeing are being refracted. Refraction is the bending through a medium. It's why our sky is blue. If you see the little illusions out in front of you here in the summer when you're driving on a freeway and you see like a puddle and then all of a sudden it disappears when you get there, that's a refraction. So a rainbow is the bending of light through a medium. So the result of a rainbow is refraction. So refraction is bending through a medium. If you put a light wave through a prism, it bends down. Well, sound does the same thing. When you don't see it, so you don't recognize it and you don't notice it, but sound can have a refraction as well, bending through the medium, because as you enter a new medium, the wavelength, remember, changes. That changes the speed of the wave. When it comes back out into air, it bends back to its normal wavelength, moves back to its normal speed. So speed is controlled by a change in medium, and so is wavelength, because remember, speed or velocity is wavelength times frequency, and remember, frequency doesn't change. So as I go through this medium, I get bent. Another term that you're going to need is diffraction. This is a bending around an object. You see this, if you've ever seen a diffraction grating, you would notice it, but you see it in light a lot of times because like dusk and dawn, the sun's gone, it should be dark, but the light is actually bending around the earth, so you still see for a while after the sun is gone. It's still light out, and it's not as light as it was when the sun was up, but you can still see it. You also notice a change in the size of the moon as it rises, or the sun rises, and as it goes up it gets smaller. This is bending due to going around something, and the something it's going around is Earth. The moon, that full moon, when it rises, is huge sometimes. It's also a different color, which we'll talk about later. But when it goes up in the sky, it gets smaller, and then it becomes more white. And that's diffraction, bending around an object. Now, there are two kinds of waves, mechanical and electromagnetic. Now, these are types of waves. Mechanical is ones that need a medium. Sound waves, water waves. Medium means what is it traveling through. Without the water, a water wave can't exist. If you had a rope or a string doing that, the string is the medium. If you were talking about a sound wave, that's a pressure wave. It happens through air. Air becomes your medium. These are all mechanical waves. That's this unit. The next unit is going to be electromagnetic waves, and those are waves that don't need a medium to travel. Light, X-rays, gamma rays, infrared, ultraviolet, all those light waves, or those terms you recognize with light. Light's only, by the way, the visible part of the electromagnetic wave spectrum. But those are light waves, and they don't need a medium to transfer. Can they go through a medium? Absolutely, they do all the time. It's what causes, that's why they use X-rays to battle cancer. They shoot through the medium of your flesh and bone or whatever to kill the cancer. So electromagnetic waves can go through a medium, but they don't need one in order to travel, which is one of the reasons they're dangerous. The other three terms, standing wave, simple harmonic motion, is, remember that harmonic motion, it's called simple harmonic because it's how we create sound waves that we enjoy. We'll get to that in the next video. And then there's this Doppler effect, which is that observed change in frequency. It seems to be changing, but it's really not. So we're going to play with all of these concepts in your next video.